What if the secret behind producing the perfect glass of French wine actually unlocked the ultimate medical weapon to save human civilization? This epic scientific revolution kicked off when Louis Pasteur began his brilliant career as a professor of chemistry at the University of Lille, France. He started by diving deep into the industrial manufacturing of wine and beer, aiming to help his neighbors produce a consistently high-quality, uniform product. By examining countless batches of ferment under the lens, Pasteur made a groundbreaking discovery. The fermentation of fruits and grains into alcohol wasn't a chemical accident. It was actively driven by microscopic living organisms. He proved that good batches were dominated by one healthy type of microbe, while ruined, poor products were crowded with entirely different, undesirable strains. To save the industry, Pasteur proposed a legendary fix. He suggested gently heating the liquid just enough to destroy the vast majority of the unwanted microbial population without ruining the delicate flavor. Ultimately, he proved that holding the juices at a precise temperature of 62.8 degrees Celsius, 145 degrees Fahrenheit, for exactly half an hour, completely did the job. This initiated the process we universally call pasteurization, a technique that remains vital today across global fermentation and the modern dairy industry. But this mind-blowing revelation that invisible organisms could actively sicken and spoil a beverage instantly ignited a terrifying question. If microbes could destroy wine, could they be doing the exact same thing to the human body? Long before Pasteur's definitive proof, visionary students had fiercely argued for the germ theory of disease. Fracastoro of Verona had early on suggested that illnesses were transmitted via invisible organisms. Later, in 1762, von Plensis declared that living agents caused these ailments. He brilliantly suspected that entirely different specific germs were responsible for different, specific diseases. This fascinating concept of unseen biological parasitism was becoming so popular that the famous satirist Jonathan Swift, 1667 to 1745, even captured it early in the 18th century with his iconic doggerel. Big bugs have little bugs upon their backs to bite them, and little bugs have smaller ones, and so ad infinitum. By the 19th century, this theoretical warfare turned into a medical crusade. The scholarly physician Oliver Wendell Holmes, 1809 to 1894, insisted that puerperal fever, a deadly childbirth infection, was highly contagious. He argued it was actively carried from mother to mother by unwashed midwives and doctors, publishing his definitive work, The Contagiousness of Puerperal Fever, in 1842. Simultaneously, Hungarian physician Ignaz Philipp Semmelweis, 1818 to 1865, was pioneering the revolutionary use of antiseptics in obstetrical practice. He dramatically crashed maternal death rates by minimizing infection channels, leading him to publish his monumental text, The Cause, Concept, and Prophylaxis of Childbed Fever, in 1861. Yet tragically, the medical establishment stubbornly ignored his life-saving advice. It wasn't until around 1890, when the pioneering work of Joseph Lister in England finally became known, that the entire medical profession fully appreciated the absolute necessity of antisepsis. Seizing on this momentum, the French government officially requested Pasteur to investigate piperine. This was a devastating silkworm disease that was completely obliterating a vital national industry. After years of heartbreaking struggles and continuous disappointments, Pasteur triumphantly isolated the destructive protozoan parasite causing the disease. He taught farmers a foolproof system to eliminate it by using exclusively healthy, disease-free caterpillars for breeding stock. Emboldened, Pasteur turned his attention from silk to wool. He tackled the deadly problem of anthrax, a brutal disease ravaging cattle, sheep, and humans, successfully isolated the microbes from the blood of dead animals and cultivated them right inside his laboratory flasks. Meanwhile, across the border in Germany, a quiet, meticulously precise physician named Robert Koch, 1843 to 1910, working in the shadows, occasionally neglecting his own medical practice to play with the fascinating infant science of bacteriology, achieved a historic milestone when he discovered distinct, square-ended bacilli floating in the blood of anthrax-killed cattle. Koch systematically grew these bacteria in cultures to guarantee only one specific kind was present. He injected them into healthy animals to replicate the exact clinical symptoms of anthrax, and successfully recovered the identical microbes from those experimentally infected hosts. This marked the absolute first time in human history that a bacterium was definitively proven to be the literal cause of an animal disease. This flawless series of observations established Koch's postulates. These are the ironclad, four-step scientific guidelines we still use today to identify the true causative agent of any infectious disease. Step 1. A specific organism can always be found in association with a given disease. Step 2. The organism can be isolated and grown in pure culture in the laboratory. Step 3. The pure culture will produce the disease when inoculated into a susceptible animal. Step 4. It is possible to recover the identical organism in pure culture from that experimentally infected animal. If you want to master these hidden blueprints of life and see how humanity fought back against the invisible rulers of our planet, smash that subscribe button to join us here at Microbio. And drop a comment below. Do you think Pasteur's brilliant intuition or Koch's meticulous logic did more to save human civilization?